All right, let's get into it. Today, we're cracking open a piece of tech that has become one of the most powerful engines of the modern world. You've got one in your phone, your computer, and they run massive data centers, but they're often completely misunderstood. So today, we're going to pull back the curtain on the GPU.
So think about this for a second. What's the secret ingredient behind the incredible special effects in your favorite movies? Or the massive simulations that predict climate change? Or even the AI that you chat with every single day?
Well, the answer might actually surprise you. It's not just the computer's main brain, the CPU. The real unsung hero behind this whole revolution is the GPU, the graphics processing unit. And we're about to find out exactly why it's changed, well, pretty much everything.
Okay, so first things first, what even is a GPU? Let's peel back the layers and really understand what makes this thing tick. So, on paper, a GPU is a specialized electronic circuit. And its name, Graphics Processing Unit, kind of gives away its origin story. It was born to render images for video games. But its real talent, the thing that has taken it so far beyond just making pixels look pretty, is its absolute mastery of processing huge amounts of data, all at once.
And that right there brings us to maybe the most important concept in this whole explainer, the fundamental difference between a CPU and a GPU. It's all about doing one task at a time versus doing thousands. It really comes down to two totally different ways of thinking. Your computer's CPU has just a few very powerful cores. It's a master of sequential processing. That means it handles different, complex tasks one after another really fast. But a GPU, it has thousands of smaller, more efficient cores. Its superpower is parallel processing, doing tons of similar tasks all at the exact same time. You know, here's the best way to think about it. A CPU is like a handful of brilliant specialists. You can give them any complex job, but they have to do it one step at a time. A GPU, on the other hand, is an entire army of thousands of workers. Now, they might not be as versatile, but if you give them one single repetitive job, they can get it done almost instantly, all working together.
So how in the world does it actually pull this off? Let's take a quick peek under the hood to see how a GPU is literally built for this kind of massive parallel power. And don't worry, we'll keep it simple. The entire design of a GPU, its whole reason for being, is built around one single idea: parallelism. It's the ability to break a huge problem down into thousands of tiny little pieces and solve all of them at once.
This architecture is just built for speed through teamwork. Those thousands of cores we mentioned are absolutely key. They can all get a single instruction, like say, calculate this reflection, and execute it on their own tiny piece of data at the exact same time. It's like a conductor giving one command to 1,000 musicians. You combine that with super fast memory to feed them all at once, and the result is just an incredible leap in processing power.
Okay, so it's great at graphics, we get it. But this is where things get really interesting. Because this parallel processing superpower has unlocked a universe of applications that go way beyond gaming, and it's fundamentally reshaping the world around us.
You know the whole AI revolution? Yep, it's pretty much powered by GPUs. Training a huge model like ChatGPT involves billions of repetitive calculations. A CPU would take literally years to do it, but a GPU can run thousands of those calculations at once. And that's what makes modern AI even possible.
In science, GPUs are basically like personal supercomputers. They let researchers simulate these unbelievably complex systems, from mapping how a new drug might interact with a virus to modeling our planet's climate, all the way to simulating the collision of entire galaxies.
And in the world of finance, well, predicting the future is everything, right? GPUs can run millions of what-if market scenarios at the same time, analyzing investment risks and spotting trends in just a fraction of the time it used to take. And of course, these still dominate on their home turf. Every single time you see that stunningly realistic light and shadow in a Pixar movie, just know that massive farms of GPUs are working together to render every single complex detail. Think about self-driving cars. They have to process the entire world around them and react in milliseconds. The GPU is the brain that makes this happen, processing a constant flood of data from cameras and sensors to identify pedestrians and signs and other cars, and then make critical, split-second decisions.
And get this, they're even saving lives. In healthcare, GPUs can take the data from an MRI or a CT scan and build a detailed 3D model in seconds, not minutes.
This lets doctors spot tumors or other issues so much faster.
And finally, a lot of this power is totally invisible because it lives in the cloud. When you use an online AI art generator or stream a 4K movie, your request is being handled by a massive cluster of GPUs in a data center somewhere, doing all that heavy lifting for you.
So whether we're talking about AI or scientific discovery or self-driving cars, the common thread here is exactly the same. The GPU's unique ability to just chew through thousands of repetitive tasks in parallel has made it an absolutely essential engine of modern innovation.
So let's zoom out. What does this all mean for the future of computing? What does it mean for us?
What we're seeing here is a fundamental shift in how we build computers. I mean, for decades, the whole goal was just making a few cores faster and faster. Now the future is all about harnessing these armies of efficient, parallel workers.
So if you remember anything from this, here are the 3 big takeaways. 1. GPUs are absolute masters of parallel processing. 2. This architecture makes them perfect for graphics, AI, and any huge computation. And 3. Because of all that, they are now driving innovation in pretty much every field you can imagine.
So, what started as this niche component just to make video games look a little better has quietly evolved into a true general-purpose computational powerhouse, completely redefining what we thought was possible for computers to do.
The GPU is the engine that allows our machines to visualize, to learn, and to simulate our world at a scale we've never seen before. So the only real question left is, what problems are we going to ask it to solve next?